In this video, we're going to look at another application of infinite geometric series. Suppose that in a hypothetical isolated community, the local government spends $1 billion to stimulate the economy. Assume that the $1 billion is distributed equally to all citizens and that each citizen spends 80% of his or her received share of the $1 billion. And in turn, the secondary recipient spends 80% of the money that they have received. Let me fill this in. And every recipient of spent money spends 80% of the money they have received. And this cycle goes on and on for n months. Part A of the question asks us to find an expression for the total spending that has been generated after n months. That is, find an expression for Sn. Part B, find the total spending that results from the government stimulus spending of $1 billion. Hint, apply the limit as n goes to infinity of Sn. Let's do part A first. So the money spent by the government initially is, of course, $1 billion. $1 billion. All right. The money spent by all the people who receive $1 billion is going to be 80% of that. So it's going to be 0.80 multiplied by 1 billion. And this is equal to $0.80 billion. All right, the money spent by all the people who receive this $0.80 billion will be 80% of this amount. So it's going to be 0.80 multiplied by 0.80 billion, and that's equal to 0.80 all squared times 1, and that's equal to $0.64 billion. And the money spent by all the people who received this $0.64 billion, 0.64 billion, which is just 0.8 squared, is going to be 80% of 0.64, which is 0.8 squared, and this is equal to 0.8 cubed times 1 billion, and that gives us $0.512 billion. This cycle of receiving and spending goes on and on. The total months spent by the people in the nth month is going to be 0.8 to the power of n minus 1 times 1 billion. So the total spending that has been generated after n month is going to be a geometric series. So we have Sn, that's the nth partial sum of a geometric series, is the 1 billion, that's the initial amount that the government spent, plus 80% of that, which is 0.80, plus 80% of 0.8, which is 0.8 squared, plus 80% of 0.8 squared, which is 0.8 cubed, and goes all the way up to the nth month, which is 0.8, to the power of n minus 1. Now, it's clear that Sn is a finite geometric series with n terms, with a is equal to 1 as a first term, and a common ratio of r equals 0.8. That's the common ratio. The common ratio is the ratio of two successive terms, so we can just say 0.8 divided by 1 gives us r equals 0.8, or you can say 0.8 cubed divided by 0.8 squared, that also gives us r of 0.8. So now let's apply the formula for a finite geometric series. Sn is equal to a times 1 minus r to the n divided by 1 minus r. So Sn is equal to, let's write down the expanded form of this finite geometric series, 1 plus 0.8 plus 0.8 squared plus 0.8 cubed plus all the way up to 0.8 to the power of n minus 1. Sn is equal to, a is equal to 1 times 1 minus r, which is 0.8, to the power of n, divided by 1 minus 0.8. So we get 1 minus 0.8 to the power of n, and divided by 1 minus 0.8 is 0.2. 1 divided by 2 gives us 5, times 1 minus 0.8 to the power of n. So this is SN, which is the total amount of money that has been generated after n months of receiving and spending. So let's write down after n months. All right, part B. Find the total spending as n goes to infinity. That means find the sum of the infinite geometric series. From part A, we found that Sn, the nth partial sum of this geometric series, is equal to 5 times 1 minus 0.8 to the power of n. Let's take the limit as n goes to infinity of Sn to find the sum of this infinite geometric series. This is equal to limit, distribute the limit n goes to infinity of 5 minus limit as n goes to infinity of 5 times 0.8 to the power of n. Limit of a constant is just a constant, so the answer is just 5, minus limit of a fraction raised to the power of infinity, of course, will be 0. So 0.8 to the n, this is going to go to 0, so the limit as n goes to infinity of r to the n is equal to 0 if r is between 1 and negative 1. So the limit of 0.8 to the n is going to go to 0 because 0.8 is less than 1. So 5 minus 0. So the limit as n goes to infinity of Sn is equal to $5 billion. So the big picture is $5 billion of total spending has resulted from $1 billion of government stimulus spending, and economists, they call this the multiplier effect of government spending. That's how they justify it. So although this is a very simplistic model, this multiplier effect provides a justification for government deficit spending to stimulate an economy out of a recession. Banks also apply this principle of the multiplier effect to lend out a high percentage of the money they receive in deposits. They lend this out to small businesses and to mortgages. All right, thanks.